So here in sodium, when we are considering as an example, 1s2, 2s2, 2p6 and 3s1 is an electron configuration, and which are 1s2, 2s2, 2p1 are the core electrons which is very near for the nucleus, and the 3s1 which is in the final shell as an valence electrons, and also it is loosely bounded with the nucleus. And these valency electrons which occupies the third atomic shell is the electron which is responsible for the chemical properties of a sodium. And when we are going to consider sodium atoms together to form a sodium metal, when we observe this diagram here, what I mentioned, in this, these electrons which are revolving around the nucleus, there are the possibilities of the same atoms here and here, but these two I am discussing in the next slide what it will be happen. Here the electrons which is revolving around the nucleus of its individual atom itself, but these electrons are not interacting with the other atom's nucleus. So here generally the sodium has a body centered cubic structure, and with the distance between the neighbor atoms is 3.7 angstroms. The radius of the third shell, that is which is a final shell in sodium, is 1.9 angstroms. So solid states of general sodium atoms overlap slightly. From this observation, it follows that a valency electron is no longer attached to a particular ion but belongs to both neighboring ions at the same time. If you observed in this diagram, a valence electron really belongs to the whole crystal, since it can move readily from one ion to its neighbor and then the neighbor's neighbor and so on. These mobile electrons become conduction in electron in a solid, which will be observed in this. Now these electrons will be interact with the whole crystal with its neighbor atom's ion core, which will make an attraction of an electron with the neighbor atom nucleus will attract the neighbor atom electrons. In this way, the electrons will be conducted whole over the crystal. The removal of valence electrons leaves a positively charged ion. The charge density associated with the positive ion cores is spread uniformly throughout the metal, so that the electron moves in a constant electrostatic potential. All the details of the crystal structure is lost. This assumption is made. According to the FEM, which is termed as free electron model, this potential is taken as zero and the repulsive forces between the conduction electron and also ignored. Thank you.